Welcome everyone to our Resource YYC Lunch and Learn today. Today we have one of our members, Carla, presenting, and I hope you'll enjoy. In case you're not aware, Resource YYC is a co-working community for professionals. We have office spaces, dedicated desks, virtual office options, as well as drop-in options. So if you're ever in need of a space in Calgary, come check us out. Over to you, Carla.
Thanks everybody for coming today. So today I'm going to be talking about environmental monitoring, which is one of the areas of specialty for my company. We run a small company called Endeavour Scientific, and we do knowledge translation, government relations, and environmental monitoring. So before I jump in, this talk I'm kind of testing out how technical to go. So I thought there's a small group today, so let's just let's have a conversation as we go along. And maybe we could just start. Does everybody want to maybe introduce themselves and maybe give me just why you're interested in this topic and maybe what your background is?
Oh, so everybody unmute. My name's Terry Day. I'm a geologist, and I guess I'm just interested in learning a little bit more about this environmental monitoring, and just to see, there seems to be lots of work out there or jobs offered in this type of environmental stuff. So just interested to learn.
Cool. Thanks, Terry. Maybe Chris?
Hello. Chris Best. I work in the power industry as a consultant, and I'm not very familiar with cumulative effects, but I've heard about it in people trying to permit plants and projects, and so interested in learning a bit more about that.
Great, thanks. Frank?
I have a friend who his wife is very much involved in the Indigenous communities in Alberta, and so I was just going to glean some information and pass it on to him. Is what I was, because I saw you're affiliated with
Yes, yeah.
Few, right?
Yep.
So I thought there might be a connection to be had there. So.
Oh, that's fantastic. Thanks. Okay. And Shelby, you can just say that I have to be here.
Well, I do find this interesting as well, because I have a background kind of in archaeology, so kind of
cool.
Bringing in, and yeah, it's kind of interesting for sure.
Great. Okay, thanks. And Rosemary?
I'm your host, but also I think environmental monitoring is really important, and it's just always something that's kind of nice to have more knowledge on, because it's constantly changing and affecting how we live. Okay,
great. And also I see a note here from Frank that no mic or camera, background's oil and gas. So that's great. Oh, and Gail's here. Sorry, there's a bunch of people online that I can't see. Oh my gosh, everybody's showing up. Hi, Gail. You want to give an intro, Gail? Oh, it isn't working. Okay, we'll come back. And Greg.
Can you hear me okay?
Yes.
Okay, so I'm a geologist in the oil. I was a geologist in the oil and gas industry, and I've just completed my master's in sustainable energy development at the University of Calgary, and I did my my capstone project on using mapping tools to improve the integration of Indigenous knowledge and science into EIAs. And I use the Site C environmental impact statement as the source of most of my information. So I was basically mapping both traditional knowledge, Western science, and then comparing the two. And I made a cumulative effects map that was part of my capstone research, which included all the activities in and around the Site C area, and within the Blueberry River First Nation and Kelly Lake Métis Settlement Society traditional territories.
Oh, we should chat after. I know some people work for Kelly Lake.
Yeah.
Okay. So thanks everybody for coming. And so this is good. Now I know everybody has a somewhat technical background, so I'm going to talk about hypothesis testing here, but I promise no math. That's not true. There's a small amount of math. So I'd just like to start with a territorial acknowledgement. So I'd like to acknowledge the traditional territories of the Blackfoot Confederacy and the people of Treaty 7, which includes the Siksika, the Piikani and Kainai, the Tsuut'ina and the Stoney Nakoda First Nations, including Chiniki, Bearspaw, and the Wesley First Nation. And this is when I was with the university. This is in land that's adjacent to where the Bow River meets the Elbow River, and the traditional Blackfoot name of this area is Mikisew. This is now Calgary. And the city is also home to the Métis Nation of Alberta Region 3. So I'd just like to start with an acknowledgement. We are all treaty people. And just I want to express gratitude for living and working in this landscape. So a bit of background to the work that I do and the why. And excuse me, when I started my business in 2012, you know, the issue of how do we talk to each other over contentious decisions or contentious issues, how do we make decisions in contentious issues was problematic, but it is even more so now. And so what I'm showing here is, as we know, the whole argument over what is real, even what constitutes truth, has suddenly become very problematic. And so I got involved in this because I was really curious about how do we bridge the divide between very disparate points of view. And one of the ways to do that is to really break it down into what is the evidence and how can we interpret that. And so the driving synthesis for my business is really encapsulated in this quote, which is that we really need to actively work to understand complexity, respectfully engage people where they're at, and build the infrastructure to enable people to hear and appreciate different perspectives. And that's what it means to be truly informed. And so one of the ways to do this is, especially in the area of landscape management, is to monitoring is one of the ways to really understand what is going on with the landscape and how do we make decisions about that. And now I said that this is in the context of cumulative effects, and this is a really thorny question. So what are cumulative effects? So if I just asked you guys, what are cumulative effects? What are some of the things that come to mind?
Any sort of development related to industrial activity. It could be agriculture, it could be hydro, it could be oil and gas activity, new coal mines, any sort of impact on the environment that accumulates over time.
Okay, so that's accumulating over time is part of it for sure. But I would argue that some of those are just stressors. So what makes cumulative effects cumulative effects?
Well, each one will have an impact on the environment. Is that where you're heading?
Yeah, so the point is that cumulative effects is a way of expressing that there's multiple things happening on the landscape. Sometimes those effects are additive. So, you know, what you see, you know, say a culvert over a stream has an impact on that local area, and a culvert over here has an impact on those local area. And the two being close to each other doesn't really change anything. But sometimes those effects are actually synergistic. So what you might see is a combination of two stressors is actually bigger than you would expect from the sum of its parts. So cumulative effects is really thorny because it's conceptually hard to define and it's mathematically hard to define. And in the context of environmental monitoring, sometimes that complexity just gives us a get out of jail free card, which is something that I want to talk about as we go along. So if we look at some of the government definitions of cumulative effects, they're all similar. So they're from the government of B.C, cumulative effects are changes caused by the combined effect of past, present, and potential future human activities. In Alberta, again, similar human activities from past, present, and reasonable foreseeable future have an impact on the environment. When all of these activities are combined, they interact and the pressure can exceed the environment's ability to recover from disturbance. So the concepts here are that they are impacts that accumulate over time. They're from multiple stressors, and sometimes the combination of those can cause an effect that is greater than you would expect. So I'm just going to give you some examples. So this is some work that we did looking at air quality impacts in Fort McKay First Nation. So I've worked with Fort McKay First Nation for about almost 10 years now. And one of the really big concerns of Fort McKay is air quality. And so Fort McKay is right in the middle of the Athabasca oil sands region. So what you see here, here's Fort McMurray, and here's Fort McKay. It's a tiny hamlet of about 600 people. And it is almost completely surrounded by oil sands mining and in situ operations. So what community members, and actually I was in the community just last week, what community members express is a lot of concerns about odors and dust. And part of the reason for that is that, you know, with all the industrial development surrounding it, there's odors arising from mine faces, from tailings ponds, from flaring. And then dust is also quite prevalent due to the density of roads, but also, you know, just wind blowing off of mine faces, or blowing off of stockpiles of pet coke, or blowing off of, you know, thin lift drying. So some of the work that we did was looking at what are different ways of assessing air quality and how that air quality is impacted by oil sands. And the important thing here is that we're not so much interested in saying there's cumulative effects to air quality and it's bad. That's where monitoring is ineffective. Where monitoring is effective is saying there's impacts to air quality. It's from these stressors, it's these compounds, and these are some of the ways that it can be addressed. And then what you see on the right here is some other work that we did looking at the effects of ambient air quality on forest health. And so it was really interesting what we found over time. You see with these graphs, this is again the mineable oil region. And as time goes on and more stations are added, the area for which there's interpolated data gets bigger. But you can also see that the ambient concentrations, in this case NO2, increase over time. So just another example, this is a Landsat image of the mineable region in 1984. And so this was the original Syncrude. Somebody tell me if I get Syncrude and Suncor mixed up, because I always do it, and I'm going to apologize right now. I've been in this for 10 years and I will always get them mixed up. It's terrible. Anyway, the point is, and then Fort McKay is just right about up in here. That was 1984. And this is 2011. And if you look at more recent maps from about 2020, it looks quite similar. So the point is that for the community of Fort McKay, cumulative effects aren't just an academic concept. This is actually part of their lived experience. A bit closer to home, I was just looking at this morning. This is really interesting. This is South Calgary. This is what it looked like in 1982. And my house, where it is now, is right about over here somewhere. And this is what it looks like in 2021. So this is to say that impacts to the landscape are ongoing, and this is how change over time. And certainly in the urban environment, cumulative effects are quite significant. So that's what cumulative effects is like. And so what does effective environmental monitoring have to do with cumulative effects, and what makes environmental monitoring effective? So this is a huge question, and I think one that we struggle with, and I mean being society in general. And I want to make it really clear, effective environmental monitoring is not the same thing as academic science. And this is part of the problem that we have, is that most scientists are very much driven by a career model that emphasizes, you see here on the right, answering hypotheses that can be very broad. The intent is to add to the body of knowledge, and the output from that is scientific publications, patents, stuff like this. And that's great. I'm not ever going to say we shouldn't have academic science and pure science. That has a very big and important role in society. But what I want to point out is that if the output is scientific publications, getting a paper out, for those of you who've drafted papers and gotten through the publication process, takes a long time, long time, you know, upwards of a year. And sometimes the hypotheses that come out from academic science are quite a bit broader than we would expect to see in environmental monitoring. So environmental monitoring, what we're looking for is specifically, it is hypothesis driven, but we're looking very specifically for change in the environment that can be attributed to a specific cause. and that cause is related to stressor on the environment. And the reason is that environmental monitoring is there to inform management. So the output should be specific, have timely results, and designed to inform decision makers. And this is maybe one of the most important things. In my work with Indigenous communities, what I hear over and over and over again is that we don't want to do monitoring just to watch our landscape decline, right? The monitoring is only useful insofar as it impacts decision making. And so I do a lot of work with the oil sands monitoring program. And as an example of this, I'm going to throw a bit of shade. It's been 10 years, $500 million have been spent on oil sands monitoring. There's been over 400 academic papers, but very few new things that we know about how to manage oil sands. And one of the reasons is that it's been very much driven from an academic science paradigm. So what environmental monitoring should be is another form of knowledge translation. And for those of you who, I don't think anybody was at my last lunch and learned about knowledge translation, this is really the process about how do we go through the process of science or make science useful to decision makers. So an integrated knowledge translation, that's a form of experimental design where essentially your knowledge users are partners in the research process. And so ideally what we would be looking at with environmental monitoring is that if your goal is to make informed decisions about land and resource management, that means the people who are involved in making those decisions should be involved in designing the program. We want to know, what information do you need in order to make a decision? So we can make sure to capture that information. So we take this a step further. Effective environmental monitoring, the latest paradigm is adaptive monitoring. And this is a recognition that as we learn more about the environment, how we monitor can change as well. So it's still part of a larger system of management. It's still intended to inform decision making. But now we design a monitoring program that evolves through feedback loops. And then that can help you accelerate or decelerate activities as necessary and can improve the program over time. So what does this mean? It means that we need to make sure that our monitoring outcomes are actionable. And again, it's not necessarily the purpose of monitoring to manage the environment, but it is the purpose of monitoring to provide the information required to make management decisions, and recognizing that management decisions require other processes. So I'm just going to stop there. Are there any questions so far?
Yeah, Carla, it's Greg here. Just wondering how were you using Indigenous traditional knowledge in the monitoring process, like rather than just doing NO2 or anything like that, and what knowledge were you using?
Yeah, that's a really, really good question. So in the oil sands monitoring program, the process of including both traditional knowledge, but also community driven and Indigenous driven monitoring is ongoing. So again, this gets back to the question of who's the decision maker here. So for Indigenous communities that I work with, they'd be looking for a suite of information that's very specific to their participation in the regulatory process or ability of members to use the landscape. And in that case, I'm going back again to this integrated knowledge translation model and working with the community to say, what decisions do you need to be making here? How can we work with the community to make sure that there's information provided to that? And essentially the goal is to empower the decision makers. Does that answer your question?
Yes. More specifically, were you focusing on like biological impacts on river systems, on specific species, or on vegetation that would affect a particular species that are related to their traditional knowledge?
It really depends. And it really depends again on what decisions the communities are trying to make. So for example, a program that I was involved in a few years ago, the community was interested in, what are the potential toxicological impacts of oil sands development? Okay, so what specifically, why are you concerned about this? What decision are you trying to make? Well, in this case, we're trying to make the decision about whether traditional resources are safe to consume. Okay, perfect. So now we want to figure out what are the traditional resources that the community is concerned about? Where are we most likely, or where are we most likely to find effects? And the reason is that you want to be asking the question in the most powerful way. And then from there, we can go on and start working with the community to answer that question.
Okay.
It doesn't
Thank you.
necessarily have to be biophysical as well. So for example, some other work that we're doing is looking also at what we would call impacts to rights. So are there impacts to your ability to access important landscapes, to pass down important knowledge, to accessing landscapes that are important for community cohesion? These are all things also that can be part, like really legitimate questions. And so I think there's a risk in assuming that rights or cultural practice can be represented solely by biophysical proxies. You know, there is a room for having conversations from a more social science lens as well.
Okay, was there, just for full disclosure too, I'm Indigenous. I'm from Mikisew First Nation in Blind River, Ontario. And so were there any connections from a scientific perspective where they were trying to connect relational connections, say between the water and vegetation, and then vegetation and the animal species? Where you're starting to get more holistic, it's not as scientifically defined. So you're starting to get into the more holistic approach from Indigenous knowledge, and then taking that knowledge and making a relational connection to environmental impacts of different species, land, water, whatever it might be.
Yes, and I agree with you. I think that's in a direction that monitoring needs to go more. I don't think it's somewhere that a lot of programs have really recognized, but there is definitely power in not only, you know, I think that part of the trap that a lot of programs fall into is thinking that Indigenous knowledge is solely there to inform the choice of indicators or locations. But what I think Oil Sands Monitoring Program is trying to get to is empower the communities, not just to ask those questions, but some of the ones that you're talking about, that not only, you know, how certain impacts travel through the landscape, what are those hypotheses, what are the relationships, and then how does that impact rights and culture? I feel like you and I could talk about this for hours.
Yeah, we probably could.
Yeah. That's great, thanks. All right, anything else? Okay, so I just want to talk a little bit more about the link between monitoring and management. So this is what I show over here. This is the adaptive monitoring cycle. So let's say that you do your monitoring, that's in the bold there, then you have to analyze the data, assess what it's telling you, and adjust the program. A lot of other monitoring programs I've seen spend a lot of money in the monitoring and not nearly enough in the other part of the circuit. But then that becomes, how does that affect management? So adaptive management should also have its own cycle of planning. How does it affect policy? Evaluate how your decisions have affected the outcomes, learn from that, and go back to planning. And it's this link to planning that actually ends up being really, really important. And the important thing is that these are separate cycles, but they should be linked by the same data. So let's focus a little bit on planning. In a really effective land management system, what you'd have is a fully synthesized system of how to assess change in the landscape at different places and try to understand why. So for example, this would be the historical or reference date. This would be what was the landscape like before there was any development. This could be our pre-development baseline. It could be the reference date. And sometimes we're starting a monitoring program from already a state that's accumulated change. So first we have to recognize that there's already been change accumulated. Then we have to start talking about what could be driving these changes. And that's the role of model development. And so your model will tell you, what do I predict is going to happen because of this particular impact? And that'll give you a prediction. And then you go and monitor it. So there should be a relationship between your predictions and what you're actually monitoring. And that'll tell you, say this is this double line here is what you predicted would happen. This dash line is what you observe actually happened. And then this dash line tell you what would happen if there was no change at all. The differences between each of these tells you something about what's going on with the system. So making an error in your prediction tells you something about your assumptions. Seeing a change in the environment tells you something about how that stressor is impacting the environment. So what is this planning? That is modeling. That's also your EIA process. So ideally, your predictions from the EIA process will help inform some of the monitoring that you're doing, and some of the monitoring should be telling you whether those predictions were accurate or not. So Greg, back to your comment about inclusion of Indigenous perspectives in environmental monitoring. This means that also understanding Indigenous perspectives and potential impacts to rights during the EIA process is also very important. That's also some work that we've done. So doing all this right means that we have to develop new types of information. So phase one, you're in a new area. There's lots going on. There's lots that you're interested in. Let's say you think that Tesla is going to be building a mega battery site in the foothills, and we're concerned that it's going to be impacting the water. Okay, so the first thing that you want to do is say what's normal for this region. So that means, okay, if we think that there's going to be impacts to the water, pick indicators around water, and start developing, understanding the variability in that data. Collect a ton of data. Then phase two, start describing what's going on there. What's driving year-to-year variations in those indicators? Can you make predictions on what next year might look like? What does the EIA prediction say? And then phase three, this cumulative effects monitoring is the process of taking those models and those predictions and seeing how different it is from what you actually measure. What we often see, again, is monitoring programs getting stuck here and just collecting a lot of data. That could be expensive, and it doesn't actually tell you very much. You need to go through these other phases as well. So in an ideal world, the model used in the environmental risk assessment would make forecasts of expected deviations from the reference status based on levels of stressors. You make a prediction about whether there'd be an increase, no change, or a decrease in the stressor of concern. That's ideally how the system would work. Just another example here. To make decisions, it's one thing to see change. It's another thing to say that change is something I should be concerned about. And that's the role of triggers. And what a trigger is a predefined level of whatever you're looking at that says this is a problem. So that was a lot. I just want to stop there. Are there any questions?
Would you say the monitoring triggers, is that the same as identifying thresholds for impacts? Yeah.
Kind of, yes. So that's a really good question. So sometimes people say triggers, sometimes people say thresholds, sometimes people say limits of change. They're all slightly different flavors of the same thing. But what's really important is to clarify, is this a monitoring trigger, which tells you to look more closely at what's happening? Is it a management trigger that tells you you need to go back and make some changes into how you're managing the system? Or is it a forecast trigger that says maybe I should make some mitigations as part of this plan to do whatever operation? Those are the distinctions that are really important.
How are they deciding what to monitor?
That is the next part.
Perfect. Can't wait.
Very, very good question. Frank.
When you establish what's the norm, is there a standard amount of time you go back? Like, is it within the last 5, 10, 100 years, right?
That is another loaded question. It really depends on what you're trying to answer. And so, for example, if your question is, what was the landscape like before industrial development, then go back to before industrial development. If your question is, what's the accumulated state now, which is quite often the only question we can answer, because often we don't have data going back that far, then the rule of thumb now becomes a question of statistical power. So how many years you need depends on the variability and what magnitude of change you're trying to detect.
Mm-hmm, mm-hmm.
It's asking good questions. All right, so the next part of this is basically how do you pick indicators? And this is probably engenders more arguments than anything else, and I certainly have a ton of opinions about it. But for effective environmental monitoring, they really have to be linked to stressors. So this picture is just an example of a really common stressor in Alberta. Does everybody recognize this? It's a hanging culvert. So often when there's a road crossing over a water body, there'll be culverts. And basically the intent of those is to maintain the flow of the water body. A hanging culvert happens when there's erosion underneath the culvert, and now there's a gap between the culvert and the water body. And this is a problem because it really impacts the migration of fish. So I remember seeing a talk about 10 years ago that, you know, sort of all the impacts in Alberta to fish populations, this is probably one of the biggest. There's so many culverts on the landscape, and we don't do a good job of tracking which ones are blocking the movement of fish. So if we were concerned about this issue, what would be the stressor?
Total dissolved solids, runoff from fertilizers, runoff from roads like oil.
Those are examples of stressors, but not necessarily for this particular issue, right? So now it's a type of stressor related to contaminants in the environment. But here we're talking specifically about impedance to fish movement. So the stressor is just, where are the hanging culverts?
Okay, so it wouldn't be the total dissolved solids or suspended sediment and the impacts on O2 levels in the water?
If you're concerned that the impacts to fish are because of water chemistry changes, yes. And that could be also a function of culverts. If you're concerned that fish can't get to their spawning grounds, then it isn't. So that's a really good point. So if we're saying, okay, fish populations are dropping, we think it has something to do with culverts. Now we have two mechanisms of effect. One is the biochemical or the chemical, and one is just physical access loss. So now, what would be your indicators?
Contaminant levels in the river system, mean chemical concentrations.
That's one of them, yep. And that's for our one pathway. What's the other one?
The amount of culverts.
Yeah, the amount and location of culverts. And then what would be another one? What are we trying to fix here?
The fish.
The fish, yeah. So where and when, how many fish, where are they? Are they healthy? All that sort of stuff. So just to give you an example, here's an example of a totally hypothetical graph. So let's say there's a coal mine. We're interested in how is the coal mine affecting bird populations. What this shows you is that this is the distance to the mine along the x-axis, and this is the number of birds. So what does this tell you about the bird populations? See, I told you there'd be math.
Well, they're improving away from the mine site.
Right, for which species though?
Looks like all of them.
Yeah, all of them, but for bird 1 and 4, there's a much bigger effect.
Correct. Yeah.
Okay, so does this tell me anything about how to manage the mine?
I guess you'd have to know what the impact on the birds were.
Exactly. That's exactly it. We need to know exactly why the birds don't like this. So let's say we do some more studies. So let's say we look at the levels of noise, and then we look at input, like the density of linear disturbance. Now what are we seeing?
Can you define what you mean by linear disturbance? That first one, I don't quite understand that.
Oh, sorry. What that means is if you look at, like, if you ever flown over a region with a lot of seismic, right? And you'll see in the forest, there's a lot of grid lines.
Yeah.
What we would say there is that that's a really high density of linear disturbance. And all that means is that there's a lot going on in the landscape. And what we find is that, especially with birds, some birds like really undisturbed interior habitat. They don't like to have a lot of roads or seismic around. Other birds actually really like it. So what this is showing is that some birds are responding to, say, 10 kilometers per hectare or something like that. They're responding to linear disturbance quite strongly and other ones aren't. Whereas some other birds are responding more to noise. So now does this tell us how to manage the mind better?
It's getting you closer.
It's getting us closer, that's right.
Yeah.
So because noise and the density of linear disturbance are things that we can manage, right? So the closer that you're monitoring tells you about actual impacts that you can manage, the more actionable it is. So there was a really good example of, again, going back to the wildlife toxicology, we were working with a group out of Environment Canada, did some really fantastic work with the communities. The guy's name is Phil Thomas. And what he was finding was around certain camps, there is a high density of fur bearers, like small animals, that had really high concentrations of a rodenticide. And so he went to COSIA and they're like, this is an issue, what's going on here? And COSIA's like, oh, well, they're using rodenticide to try to control the mouse population on site. And once they showed, okay, well, this is the stressor, this is where it's coming from, it was actually quite easy for industry to go back and find a different method of trying to control mouse populations. All right. So this is all to get at how do you choose indicators. So indicators can be chosen for 3 different reasons. They can be tell you something about the stressor pathway. So getting back to the culvert example, it can be total dissolved solids in the water column. It can be where the culverts are. They can tell you about community concerns. So back to the wildlife toxicology example, the community is concerned about the potential concentrations of compounds in traditional resources. Or they can be there to capture an unanticipated effect. And this is where the cumulative effects management comes in. And I'll get to that in a minute. So distance to the source is really commonly used in environmental monitoring programs, and that's fine. It might tell us that something's going on, but there's nothing actionable in that. And so we really have to make monitoring more actionable and more useful. And it can be really complicated. Not all change is linear, not all change is a trend. We have to talk about how we find change. And you really need to spend some time with the data to figure out which indicators do this well. And so I'll give you an example. Going back to our example of the culverts, measuring the culverts and the water chemistry, this is an example of measuring the stressor, which we need to do. And if you see changes in stressor concentrations, you see those changes almost instantly as they happen. And once you see them, it's easy to reverse it. So they happen very quickly in time and they're very reversible. The next thing you'd say is, okay, is that stressor having an effect on the soil or water air chemistry? It takes a little bit longer to find it, but once you find it, you can still reverse it. Then you start looking at, okay, is this change in soil or water air chemistry being noticed by the organisms that are there? And you can look at biochemical responses in sentinel species. So these would be species that are really sensitive to this particular stressor. Again, if you see it, it takes longer to see it and it's harder to reverse. Then what happens next, if there's biochemical changes that become too much, it starts to affect the organism's health. If the organism's health gets impacted too much, then it starts to impact the population health and then ecosystem health. So what you need to be doing is selecting a suite of indicators that are along this pathway. The risk of measuring everything here is that you'll spend millions of dollars on chemistry and it's not going to tell you anything useful. You don't know whether this is having an impact. The risk of measuring up here, measuring a lot of biodiversity indicators, it's going to take you 20 to 30 years to find change. Once you find change, you don't know where it's coming from and you can't reverse it. So this is why we need to understand the potential impacts of stressors and try to monitor things along that pathway. And this is specifically from a Western science perspective. But there is, as we were talking about, this isn't the whole part of it. So there are the stressors based, there are the effects based, but there also has to be monitoring that is driven by the concerns of the people who live there. And they have to answer the questions and empower the people who are dealing with those changes. So the stressors tells you what the known risks are. This community driven tells you, ensures that the community's values are protected. And then effects based, this not only tells you whether what you're seeing from the stressors is having an impact, but the interesting thing is that sometimes you'll see effects on the effects based that will tell you something unanticipated about what the change is. So I'm going to give you an example of that. In one of the programs that we work on, we're looking at forest health. And the original hypothesis was acid deposition is going to impact forest health. So the program is designed to measure acid deposition, soil chemistry, lichen chemistry, foliar chemistry. Then does it start impacting the communities? And what we found actually in our 2012 survey was changes in understory community. That's interesting because we're not seeing any acidification impacts here. But what we were in fact seeing was eutrophication impacts. So this was an example of where an effects-based indicator was picking up a change that was unanticipated from our understanding of the stressor pathway. So unless you have both, you're running a risk.
Can you define that a little bit more, the understory community, please?
Yeah, sorry, plants underneath the trees. So this would be like the bushes, grasses. So that diversity was changing. And it wasn't because of acid rain. It was actually because there's so much nitrogen in the atmosphere, it was acting as a fertilizer.
Okay, thank you.
No problem.
Is that the official term for that, understory? I always thought of it as undergrowth.
Yeah, undergrowth, understory.
Okay.
Yeah. I love these. Part of what we do is scientific communications, and I love being caught sometimes using words that are really technical that I thought everybody understood, but they don't. So yeah, be sure to catch me. Okay, so that's indicators, and that's a lot, and that's only part of it. The other part of doing this is making sure that you understand or that you select indicators that have enough power to tell you that something is happening as soon as possible. So there's a lot of work that goes into choosing indicators. Any questions or comments on that?
I always wonder about how effective this information is in getting through to the people that make decisions.
That's a loaded question. It really depends. The reality is policy decision-making and regulatory decision-making use scientific evidence as one part of the decision-making suite, but it certainly isn't the only thing. So part of the barrier is really designing information that is useful to decision makers. So I would argue in Alberta's land use management planning process, a lot of the indicators that are in a lot of those management frameworks are poor. They're very poor. And they don't do enough to inform decision making. That's part of the problem. The other part of the problem is that it's decision making at the government level is like sausage. You know, you get something out of it, but nobody wants to see how it's made.
Yep.
All right, and this is the other part that's really difficult for decision makers. And it's how do we deal with uncertainty? And it's funny when I see, you know, scientists who are talking to decision makers, talking to non-scientists. There's a relationship that scientists have with uncertainty that you kind of get used to dealing with uncertainty. That's why it'll be really hard to ever get a scientist to say, oh, yeah, that's definitely going to happen, right? That they very rarely say that. And if they do say that, then there's other things going on. But communicating that uncertainty is really difficult. And conceptually, in our brains, dealing with uncertainty is difficult. And so this is really interesting. Back in 2010, this is one of my favorite guidances. The Intergovernmental Panel on Climate Change published guidance for treating uncertainties. So how do you use language that is clear about what level of uncertainty you're dealing with? How are we going to quantify uncertainty and explain that to decision makers? And it's really, really useful. And I wish it would be something that people would use more. In the world of environmental monitoring, we're often almost always dealing with not enough data. And so understanding and being really rigorous and quantifying uncertainty becomes really important. So this is where I was really wondering who has a background in hypothesis testing here, because this particular slide is tricky. But I'll give you the Coles Notes version. When you test a hypothesis, you'd say, I think that stressor X is going to have this impact on the environment. You collect your data and you do a statistical test. And it is a test. It's a way of measuring or allocating variability to different scenarios. And it'll give you back a number. And the number gives you a probability of essentially this hypothesis being untrue 19 times out of 20. Those details don't matter. What matters next is what decision you make with that. So there's a bunch of different scenarios that could happen here. Let's say in reality, your null hypothesis, so that nothing's going on here, is true, and that your testing finds out that that's also true. That's great. Your test and reality match up. You don't have to worry about it. But let's say you think the null hypothesis says nothing's going on here. Your test says, actually, something is going on here when it actually isn't. That's an error, and that's called a type 1 error. And what happens here is now this is, in a management sense, going to try to get industry to fix something that isn't broken. And that's a risk, and there's a cost associated with that. On the other hand, let's say you do know that there's an effect of whatever the stressor is, your testing finds it and it agrees, that's fine. But now let's say there's another type of error, that there is an effect on the environment, but your monitoring doesn't catch it. That's a type 2 error. And what is that? That's when you're ignoring damage that isn't real. And that's a cost to the environment. So you have to understand that any monitoring system that you set up comes with it a set of risks. And the risk is either that you find a change when you shouldn't have, and that's a cost to industry, or you don't find a change that you should have, and that's a cost to the environment. And the way that we deal with that is changing, this is all about changing your decision-making matrices. So now if you're making a decision, we can say, mathematically, this is the level of confidence that you need to make this decision. And what most monitoring programs are going to right now is saying that your type 1 error should be equal to your type 2 error. So the risk to industry is the same as the risk to the environment. And that is, again, another important distinction between monitoring and environmental science, or academic science, sorry, because academic science doesn't balance these two probabilities. So there's two types of protection you need to worry about. So this is protection from finding a response that wasn't real. That's a false positive, or protection from not finding a response when it does exist, or a false negative. So you can set up your monitoring system to help account for these. So a false positive, okay, a monitoring system can say, instead of having one statistical result leads to a decision, you could say there has to be a suite of results that make sense, that goes together. And then we think that something's actually going to happen. Or if you trigger something, there's a statistical change, then you go back and you investigate it and see if it's really true. On the second case, a false negative is harder to find. But again, that's where having an indicator that can can detect changes from a broader suite of what you think is going on, is kind of like your fail-safe. It's your backstop. So if you see change there, then you know something different is happening in the environment. There we go. So there's a lot to unpack with uncertainty here, and this is probably the most technical part of the whole talk. So is there any questions here?
Yeah, I guess that's one of the challenges with coming at it from a Western scientific approach, is this is where you get clogged up in the data. When I was reading through the traditional land use studies of all the Treaty 8 nations, and then I was going through all the Western science data that was part of the environmental impact statement, I was looking at the impacts to, you know, species, birds, bats, insects, vegetation. And when they didn't have enough data, their predictions were kind of useless. They were 100% useless when they had the answer there with traditional knowledge, but they refused to look at it because they put the scientific perspective ahead of everything else. Like an example was my grandfather, my Anishinaabe Mishomis. He was basically a hunter, trapper, guide, fisherman. He guided for Henry Ford, for Gordie Howe. He raised 16 kids off the land. So he obviously knew what he was doing. Like he understood ecology, the environment, you know, meteorology, the impact of impacts on the environment, on the behavior of animals. So he understood everything the way it was. So he was actually he already had the answer. And one of the challenges for him was, he said that he wished that he could, someone from our nation could speak to the white man and tell him what he was doing wrong. So his challenge was breaking it down into the individual scientific principles so that they could understand the impacts that they were having. But he already knew what they were, because they were happening before him. And because of that holistic approach, he understood what was happening, but he didn't know how to explain it in the scientific. And that's where sort of the gap in the knowledge exists, where, you know, some of the traditional Indigenous knowledge, they've already got the answer there. But there's sort of a little bit of unwillingness for the scientific community to accept it, but yet they'll get hung up in details of the data where they use a huge amount of data that will actually get them nowhere.
Yeah. I'm so, yes, just 100% yes. And I'm so glad that you said that. And I think there's a few things there. One thing, I saw a talk by an academic from Memorial University in Newfoundland. Her name is Mikisew Cree, and she's Métis from Northern Alberta. And one thing that she really emphasized that I just loved was that it isn't the role that if all you're doing is trying to include traditional knowledge into a Western decision-making framework, that's not enough, right? That is essentially another kind of consumptive colonial approach.
It's impossible to do, in my opinion, because they're two completely different perspectives and they kind of run in parallel with each other.
Yes. And what is needed is more equitable mechanisms of including Indigenous people in decision making. So it shouldn't be the burden of Indigenous communities to say that their lived experience is explainable under a Western lens, right? It should be that the decision-making processes are shared with the people in the landscape.
Yeah, well, you know, when I was looking at the site CEIS, one of the things I found was the amount of money that was spent on these scientific studies. You know, and I know they were trying to come up with answers, but they were just coming at it from just a pure scientific approach with very little data. So they would go out for a season, you know, a summer, they would do it over maybe 2 of these over 10 years. Well, that's not much data to work with. And then trying to draw conclusions from that are extremely difficult, and they're going to be highly inaccurate when you've got, you know, Indigenous people that are working in the field and they've seen the impacts that's happening over time. So kind of using that knowledge and kind of working it backwards almost to identify, okay, well, what are the things we should be looking at? First of all, what are the impacts on water levels? What are the impacts on species? And then how are these impacting, humans? And then determining from looking at it backwards, then you identify, okay, well, what should we be studying? So we see change, and that's where you get that relational connection where Indigenous knowledge really has a higher hand on Western science, because they kind of understand everything in a relational way, where science is breaking it down into their individual components and they're not connecting it. And I think that's what's part of the problem is.
Yes, but I'm going to say that there's a but, because I completely agree with you. But I think that what you're seeing is, in a lot of cases, just bad science. Right.
Yes.
So
Yeah,
science
sure.
and hypothesis testing is very reductionist. And going out for one season and collecting data is just bad science. That's not going to give you enough data. But that's where the modeling is bringing things back together and trying to understand some of the relations from it.
So when you're modeling, how far back are you going? So you've got data, and then you're trying to project into the future. So when you're trying to project in the future, do you pick a time frame that's appropriate for understanding the impacts that occurred over time? So if you're looking out 5 or 10 years, or should you be looking at 40 or 50? Do you understand what I'm saying? Yeah.
It all depends. And I could do another whole talk on effective modeling. But I think you and I, let's have a talk about this a little bit later, because there's a lot to unpack here.
Okay.
But
sure.
again, I think a lot of the issues we see are because science is a bad approach, but that it is done poorly, and modeling is done poorly. And we do see a lot of that. I'm not going to say that all of them, but in general, that is a thing.
Yeah, I was actually surprised at how much I saw on that, the site CEIS, how much bad science there was.
Any other questions? I think we're just about out of time, but that's okay. This is the last slide here. Oops, I'm not doing that one. So everything is cumulative. Things are complicated. Good monitoring and modeling can start teasing apart whether effects are simple and related to a single stressor, or they're indirect, or they're complex and there's synergies between different stressors. This requires some conceptual models, predictive models, and really good experimental design. And that's it. Frank, yeah.
What is your biggest hurdle? In a nutshell. Just...
How much time do you have, Frank?
Yeah, well.
There's a lot. I mean, it's not impossible to design a good monitoring program. It's not impossible to design good science. It's very difficult to make that useful in a decision-making context. And the other subtext to the conversation are important, and we can't discount them. But, I think scientists would like to just say, don't worry about the economy, that's stupid, or don't worry about these values, that's stupid. But that's not reality, and that's not how decision-making is made. So understanding how all of these things can come together that's really difficult. And as Greg's alluded to, especially when we're representing Indigenous interests, there's institutional barriers that are difficult.
So you need a foot in the door and someone's ear, right?
Yeah, also the best advice I ever got about government relations is that it's all about relationships.
Mm-hmm. Yeah, we'll connect. My friend's wife, she's very involved in all of that stuff. So we'll
That'd be
see
great. Happy to help.
if there's any door that can open there, right? So
Thanks.
All right, well, thank you very much, Carla. We've got a few thanks in the chat as well. So I think everybody managed to get some good information out of that.
Yes, absolutely. Just a question, Carla, I'd like to reach out to you. Where can I get your contact information? Or
I'd love that. Rosemary, do you have everybody's email address?
Yes, I will send them to you.
Okay, thank you.
Great,
I'll
thank
shoot you a line. Thanks, Greg. Yeah, it'd be great to chat. I feel like we have lots to talk about.
Okay, thank you. Great talk. That was awesome.
Thanks.
All right, well,
Yep.
Thank you everyone
so
for
much,
joining
Carla.
us.
Thanks, Gail.
Have a good day.
Thanks, bye.